That way that anyone that happens to be uh, that wants to watch the videos later actually will get decent videos out of it. Ship east 10 units east to positive 10, north to positive 10, neutral Y, to positive 3 to 10, 3. F7 will move 7 units east because we're still facing east to 17, 3. Then we ship 90 degrees to south. Wait, R means to turn right the given number of degrees. Can you go non... Oh, I hope that that the R's and L's are multiples of 90. Okay. That makes life easier. I think all the R's and L's are multiple of 90. I'll just assert that, and if it changes, I'll change it. Direction XY. Compass equals east, and then positive to the right 90 degrees from east is south, west, north. Start state equals struct new east 0 0. Def rotate and these aren't spaced out, right? Yeah, these are just that and number. Okay. So we're just going to do this, and then... Oh, actually what I want is degrees, not direction. I want heading. And I want this to be 90 to the right, basically. Oh, I can do this actually with trigonometry functions in Ruby, can't I? If you multiply forward by like sine and cosine of the numbers, you should be able to use the unit circle to make this easier. Yeah, okay, this is gonna be... We're gonna use fancy trigonometry on this, and it's gonna be hilarious. Um, uh, comma, state.x, state.y. So then, given the current state, it's... So the four commands are north, south, east, west. If we're moving north, we don't change the heading. We're moving north, so x stays the same. My plus number. I suppose this is switch case, isn't it? It's like switch CMD. How do I write a switch statement in Ruby? Every single time. It's case, that's right. Case CMD when n I guess these are technically not supposed to be indented over that far. When east when south. You know what? We can go in news order. That's always fun. I realize that having multiple switch case statements across multiple functions just doesn't quite make sense. And then and then the last one is the one that's supposed to be tricky, right? Forward. LR, yeah. News, LR, and forward. Okay. The heading stays the same. State.y plus, or state.x plus Ruby, it's sign, right? So if heading is 90 degrees to the right, then sign, what's sin 90 again? Sin of 90 is 1. So I'm actually doing this on cosine, right? Because cosine 90 should be 0. Yeah. So cosine 90 is 0. So for the x movement should be cosine. So what's Ruby cosine? Is there a math function? It's math.cos, right? Yeah. Plus math.cos heading times state times number, state.y plus math.sign heading times number. I think it should just be that. Let's see how badly I'm off. And then I basically do a reduction where you do a input dot reduce I'm just gonna do a loop. So first I need to parse out the command and the number, right? So it's going to be cmd the number equals Ruby 6? Where is it? Zero is not a symbol. Ship state.new. We also want to map, strip off all the new lines just because it's easier. So I got an array containing f and the numbers 0. Line.chars dot drop 1 dot 2s convert array to string Ruby of chars to string Ruby. Well, hello, I've got a bunch of people here. Hope you're all having fun. Come say hi in chat if you're interested in talking with me at all. I'm still reading things. Converting arrays to strings, blah blah blah. How to implement your own conversion method. I just want you to freaking... I guess it's just sum, right? Technically. Because if you add together all of a bunch of strings together, you basically get one string. String cannot be converted to integer. Can't you just do anything literally? Okay, that's not gonna work. So I've got the literal string 1 and the literal string 0, and I want to, I guess, dot join maybe will work. There we go. Yeah, alright. So the command is f, number is that. So we've got a command, there is f, the number is 10, that is exactly what I want to start doing. And we just do state equals move of state, command, and number. And hope that, and then put the state at the end. The heading's 180. Oh, something went wrong. Something went very wrong. There should not be fractions in this. Okay, what did I do? What am I compiling coding? I am coding up Advent of Code, which is a challenge that you can do every about... It's basically 25 days of coding exercises. It was originally done back before Christmas, but I'm just lazy and haven't quite done it yet. So I've done 11 days of coding over here, and we're on day 12. This particular time, we're basically making an interpreter. So we have a fairy. The fairy needs to take evasive actions to avoid a storm. Don't quite always understand the theme, but we're interpreting 8 different instructions. We've got a fairy that moves north, south, east, and west by a particular number of value. So for example, n3 is move north 3 units. Um, it also has a left. It actually has a heading involved, so we can turn left and right, and that's what we're. So that's what these particular commands, the when L and the when R, are doing. And then F is move forward by the given value. And rather than trying to do, well, maybe this is fancier than not, but I'm actually using math.cosine and math.sine because theoretically, if I know the heading, I should be able to multiply that by the number of units, and they should be 1, 0, -1 appropriately on the unit circle. So hopefully that is understandable. And right now I'm just doing the test input here, which they've laid out exactly what happens, and I have to figure out how far we traveled. So I'm hoping to get 25 at the end of this. Just coding challenge to keep myself busy. I'm a software engineer by trade. I worked at Stripe for about 2.5 years doing more infrastructure things like this. Well, this isn't really infrastructure. This is just me messing around for fun. I also worked at Delphix for a couple years before that, and then before that I was in college at Brown University. If you have any questions about college or coding or anything like that, I'm happy to answer questions while you're hanging around here or getting a job in software engineering. Yeah. So we're getting headings are off like this. Hmm. Yeah, I try to I like being an explaining type of person, so definitely please ask questions. I enjoy teaching people. I've worked with multiple new college grads and interns over my years. And I've also been a summer camp counselor in the past, working as a at a tech company called ID Tech Camps, and I think that I'm a pretty decent teacher. I'm just being a little bit lazy right now because I'm coding in my own apartment. But definitely, please do ask questions. I get more energized when there's people around to say things. Um, I'm checking. I want to see uh, if the heading is the part that's going off, because I don't quite understand why there should be fractions like that. But I think the heading's always true, which means math.cosine. Maybe the multiplication is wrong. So I don't see how I get fractional x and y without going through f. Or I don't want to do I want to do IRB. Math. Oh, is this going to be in radians? That would be annoying. This is in radians. Okay, how do I do math.cosine in degrees? Unless I need to do a conversion, that would be a little bit much, but I suppose I could do all of this in math in pi, but the simplest solution would be to define a conversion numeric that will convert this. Oh, that's fascinating. All right, I'm going to see if this works just because it sounds wild, the fact that you can actually do this. So I guess you're extending the a class numeric, and then I should be able to just do dot degrees in here and here. I am going to. This is why I like this particular exercise, because it's just figuring out things in a new language. Okay, 11 and 20, so 31. Is that what the answer was supposed to be? No, not even close. Hmm. The heading is so the heading's 180 at the end, which is starts out correct. All right, so the way I'm thinking about this coordinate system, n is north is 0, 90 is to the right. So 90 is east, 180 is south, 270 is west, and then you go back to 0 again. So you start out facing east, which is 90. You go forward 10, go north 3, go forward 7, you rotate right 90, you go forward 11. What's, okay, so if I do a binding up try here, I should be able to at least use my the degree helper when I run this. And then so that's basically 0. So the e negative 16 is scientific notation for 0. But if I'm 180, and that's negative 1. Oh, where's the unit circle? It's been far too long since I've done trigonometry, I guess. Okay, so you're at 0 degrees. So the unit circle puts 0 degrees here. Wolfram alpha. What do we have? I want to do cosine x. Remind me how cosine x works. Cosine x starts at 1, which is you're going forward, goes down to 0, which is you're not, goes to negative 1. So this is a way of describing if our heading is 0, then you're going east. Because this is going south, this is going west, this is going north, this is going south, this is going east again. So I think my heading actually needs to start at 0, and then that makes sense, because if I do sine of x, then you start at 0, then you're going 90 degrees north. So my rotational direction is also off, because this is south and this is north. So if I flip the direction of left and right, then my math all agrees with the standard system. So when you go right, you're going more negative. When you're going left, you're going more positive, which is going up the unit circle this way. So this is positive, yeah, this is positive radians, and then you wrap around to 11. Okay, so positive radians go this way. So you're up here to degrees. This is going north. You start out here. So if you go left, you go positive. If you go right, you go negative. We're starting at heading 0, which is to the right of the unit circle, and that should just allow us to use cosine and sine without any particular modifications. And you go to 17.8, which is exactly east 17 and south 8. This should be negative 8. Oh yeah, it is negative 8. Okay, perfect. Then let's get our actual puzzle input and see if this whole thing works. Minus the floating point errors because we're using trigonometric functions. So heading 260, 1256 plus 277. Gets us to 1533. Is that the correct answer? That's the right answer. Let's continue to part 2. Thanks everyone for going on this journey with me. Almost all of the actions indicate how to move a waypoint which is relative to the ship's position. The actual actions meanings were printed on the back the entire time. North, south, east, west, L, counterclockwise, R, clockwise, F means forward. Waypoint starts indicate how to move a waypoint which is relative to the ship's position. 10 units east and 1 unit north. The waypoint is relative to the ship, that is, if the ship moves, the waypoint moves with it. For example, using the same instructions above, F10 moves the ship waypoint 10 times until Wait, what? Starts 10 units east and 1 units north relative to the ship. F10 moves the ship to the waypoint 10 times. F means move forward to the waypoint a number of times equal to the given value. Okay. Whoa, alright. N3 moves it north, the waypoint 3 units north. The ship doesn't move. All of these move a waypoint. This rotates the waypoint around the ship the given number of degrees. And this moves forward to the waypoint a given number of degrees. What the hell? Alright. So imagine you have a drone and your ship. And the drone is moving north, south, east, west precisely on the news commands. L and R means rotate the waypoint around the ship left clockwise a given number of degrees. So I'm assuming that's if you're 90 degrees, if you're like here on a command and it's slightly above and to the left, so it's like 10 units over and 1 unit up, then it's going to be over here 10 units up and 1 unit over. So it's subtract this vector, rotate the vector 90 degrees, add that vector back. Rotating vectors is, I think, a function of trigonometry again, but it's been too long since I've thought about it. How to rotate a vector trigonometrically. Right, cosine of the angle times x minus sine of the angle times y. Yeah, I remember there was just a formula for this and we just get to use it. Okay, that's good enough for me. So now we have actually a start state is a waypoint state, which is x and y. The ship no longer has a heading. So the ship, position So we no longer care about the ship's exact heading, right? Because we rotate the waypoints and then we move forward to the waypoint at given value. So the ship state equals, we're going to start at position 0, I guess. And the waypoint state equals position dot new and 10 units east, 1 unit north, which is 10, 1 in my coordinate system. Okay. We're going to have a ship state and a waypoint state. We're going to, for north, south, east, and west, return the ship state stays the same, and then we do a new position for waypoint state. North, east, west, south. This is all the formulaic stuff, so when we're going east, we're adding the number to x. When we're going west, we're subtracting the number from x. And when we're going south, we're subtracting the number from y. Okay, those are the easy ones. We're going to leave L and R for a second. When we're going F, what we're actually doing is taking the vector from state to so the vector is going to be an array. Is there a vector class in Ruby already? And positions and stuff like this? Because this will be... okay, I actually don't think I need a position struct. I think I just need to use this vector class. Right, so this should be vector 0, 0, vector 10, 1, so this should be waypoint state plus a vector containing just a number in the positive direction, so waypoint state plus a vector that's 0 number. Am I initializing this correctly? I think so. Okay. Stop. So this is going east, so this is number 0. Negative number, and 0 negative number. Okay, so now we're doing vector arithmetic. So then, when given a ship state and a waypoint state, ship state comma waypoint state equals the move given the ship state, the waypoint state, and a command and a number. And we can look at binding.price. So if we were just doing, I'm going to not use this for a second, but if we do like west 10 and then south 10, we should just be moving the waypoint at this point. So uninitialized constant vector. Gosh darn it. How is this so... Why does Ruby make it so hard to just use the code I want to use? Would it be so... would it be so hard to do this? I don't know. Okay, vector, images, illustrations, vector art. Okay, what does the vector API do? To create a vector given an array, that elements. Okay, so if let's do this in IRB, right? Vector 0, 1. I finally checked my creator dashboard and I realized why I have other people watching. Thanks, Jeff, for the host. I know you're probably long gone, but still. Uh, is it vector dot? It's not vector dot new, unless it is, but that would be weird. Vector's just not a word. Colon vector? Vector colon? No. This is not anything particularly useful. Let's close down some of these tabs. It's getting to annoy me a little bit. Alright. Is it math.vector and just no one tells you? Math colon vector maybe? This is just frustrating. Uninitialized constant vector. Well, at least that's the world we're in. I bet that it's in matrices. Vector and math matrix in Ruby. Peter Cooper in 2006. Jeez. All right. Sure. Oh, this is gonna be really old, isn't it? Gosh darn it. Since these are 2006, it's not gonna load in a while. All right. The matrix library comes predisposed. Simply require. Do I just need require vector? Is that what's getting annoying? If that's it, I'm just going to. I should not be a coder if that's all I needed. Okay. Gem install vector. Maybe it's matrix instead of vector. Okay, that changes my error. That's probably enough. Okay, there's no state anymore, right? You are just going to go away for a second, and you're going to become ship state waypoint state. Undefined local variable or method state for main object. That's fine. They're not really. Oh, this heading. That's what's problematic. So 0, -9, which what I did was I moved west 9, so I moved west 10, so I was east, so it was 10, 1, goes to 0, south 10, it goes to -9, okay. So then these basic ones seem to be working now. Cool. Next we have forward. which should be vector equals waypoint state minus ship state, and then we return ship state. So this is move the ship to the waypoint a number of times equal to number. So final ship state equals ship state plus vector times number. So hopefully it handles the vector multiplication. Just take the difference between where the waypoint is, where the ship is, take that direction, multiply it by the scale number, add that to the ship state, you get the final ship state, and then the final waypoint state is final ship state, and then final waypoint, and then the final ship state plus the vector should be the waypoint state, because basically the waypoint moves with it. And then left and right, rotate the waypoint around the shift left counterclockwise the given number of degrees. Rotate the ship around the ship right counterclockwise. So if we just start and we do F10, for example. And then we put ship state, waypoint state. Then just F10, it's moved 100 faces to the east, 10 spaces north, and the vector is then 10 and 1, and then the waypoint is additionally 10 units above to the right of that and 1 unit above that. Okay. Then the next step there, after this, is to do the rotation, which I looked up that function earlier. So given xy has length L, the rotated vector has x2 and y2. So we just do, so the vector is once again the difference between waypoint state minus ship state. So this is a vector that now points from the ship to the waypoint. We then new vector, we're going left, so this is a vector with an x-coordinate of math.cosine of beta is the, see Wikipedia on rotation matrices. This is probably helpful to glance at. Yeah, right, so it's cosine, sine, that particular matrix. Beta should be the angle we're rotating over, which should be number dot, we're going left, which is the positive direction, so it should be number dot degrees times vector dot at the 0th point plus math dot sine number dot degrees. I suppose I could just write the function, huh? Unless the vector actually has a rotation matrix somewhere. Columns, combine, row, scalar unit. Or the matrix class might also have a rotate? I don't want array, I want matrix. Oh, no, you're not doing geometric rotating. You're doing math. I want to do mathematical rotating. How do I make a new matrix? Okay, so it's just matrix given a 2D array. And then the rotation matrix is so we get that. We get negative 1 times math.sine of degree. Oh, yeah. Technically, this is the opposite of degrees. It's actually the non-degree. It's like go from degrees to radians. But whatever. Okay. Then, am I doing this order correctly? So, rows. Each argument is a row. 25, 93, negative 166. So this is my first row of cosine, negative sine, and then sine cosine. So math dot sine of degrees and math dot cosine of degrees. So now we have a two-dimensional array, or a two-dimensional matrix that's the rotation for an angle. So now we get to new vector equals vector times rotation for number, and that should be in the positive direction. And then the waypoint state is now shift state plus new vector. And right, so if you're doing array math, by the way, order matters. So the rotation matrix comes first, and you multiply that by the vector that is the position. So we've got the vector that represents the difference between the waypoint state minus ship state. So it points in the direction of from the ship to the waypoint. We rotate it by, we do the rotation multiplied by the vector, not the other way around, which was what I was just saying, which is why I say this all out loud. So we're going to rotate this vector by that number, and then we add the new vector back to the ship state. And we basically do the same thing for r, but in the negative number direction. Okay, let's see how good I am with the test. The ship at 214 South 72. 214 South 72. That's correct. The waypoint stays 4 units east and 10 units south of the ship. 4 units east, 10 units south. Seems great to me. Alright, here's our full puzzle input. We run this. We get that. We get these two numbers. Let's add them together in a calculator. $25235. Is that the correct answer? Yeah! We did it! Yay. Okay. 2 programming puzzles a day is about right for me, so I'm gonna log off. Thank you so much, everyone, for hanging out. I really appreciate it. Thank you so much, Jeff Hoogland, for the host, and everyone else that decided to stick around and thought this was mildly entertaining. Thank you, Dr. Jazzyson, for taking a couple time to chat with me. I hope that everyone gives me a follow on Twitch. Follows are free. You definitely don't even have to turn on the notifications. and I hang out on Twitter. I post about life and myself, and I'm gonna be looking for a job soon. So if you happen to be hiring and you are watching this, let me know. Thanks, everyone.